Assalamualaikum warahmatullahi wabarakatuh and a very good day to my honorable judges. Today I'm going to present on my invention with the title of Artificial Bone from Eggshell Waste. I am Associate Professor Dr. Mirhan Nabil Ahmad Salimi from the Nanotechnology Research Group at the Geopolymer and Green Technology Center of Excellence, CGOG Tech, University Malaysia Police, UNIMED. As an introduction, Eggshell or ES is an emerging abundant solid waste created from various sources such as poultry, homes, restaurant and food manufacturing industry. In Malaysia, about 642,600 tons of eggs are produced every year, and from this amount, a total of about 73,686 tons of ES waste is expected to be generated every year. This waste has potential for producing hydroxyapatite, with the chemical formula of Ca10PO4 6OH2 a major component found in bone and teeth. Hydroxyapatite is an excellent material used in bone repair and tissue regeneration. Artificial bone refers to bone-like material created in a laboratory that can be used in bone grafts as to replace human bone that was lost due to severe fractures, diseases, etc. Bone fracture, which is a complete or partial break in the bone, is a very common condition. Hydroxyapatite, which is one of the most stable forms of calcium phosphate, makes up about 60 to 65% of the bone. The structure of hydroxyapatite is very similar to that of the original bone. For the synthesis of hydroxyapatite from eggshell waste, firstly, eggshells were rinsed with water and dried in an oven at 60 degrees Celsius for 3 hours. Then, the dried eggshells were crushed into powder using a grinder. Next, powder was calcined at 900 degrees Celsius for 3 hours as to decompose calcium carbonate into calcium oxide as well as the organic matters. Then, the calcined eggshell was milled using a planetary ball mill with dicalcium phosphate dihydrous as to undergo mechanochemical activation. And lastly, the mill powders were heat treated at 1100 degrees Celsius as to obtain pure hydroxyapatite. For the results obtained, firstly, for the FDR spectra, all of the hydroxyapatite produced from the eggshell waste show very similar spectra with the commercial hydroxyapatite. This indicated that the produced hydroxyapatite from eggshell waste was very pure as compared to the original hydroxyapatite. This is also the same for the XRD profile, which all of the hydroxyapatite samples produced from the eggshell waste show the same profile as the commercial hydroxyapatite. And lastly, for the SAN micrographs, the morphology or the shape show very similar or identical shape with the commercial hydroxyapatite, which is very good to be used as artificial bone application. In terms of compressive strength testing, it was shown that the bone compressive strength range is between 9 to 11 megapascal, which is very good to be used as an artificial bone application, which is very similar to natural bone compressive strength. In terms of novelty, this is the first reported of hydroxyapatite nanoparticle synthesis with contour parameters by mechanochemical method, which produce uniform and small particle size. We have a patent filing with the patent number of PI 2014702579. In terms of publications, we have 3 publications, including one article that was published in Powder Technology Journal, which is a Q1 journal with impact factor of 5.2. For the commercial potential, this inorganic biomaterials has the potential for the artificial bone application at the global level with high impact from the perspective of healthcare. We also have collaborations with the School of Medical Sciences at the University Science Malaysia and also the Clinical Research Centre or CRC at the Hospital Tunku Fauziah Kanga Perlis. As conclusions, eggshell or ES is a natural waste produced in abundance yearly which can be transformed into hydroxyapatite powder for artificial bone application. This avoids of using synthetic chemical formations to produce artificial bone which might be harmful to humans. Thus, this innovation can also be considered as a green invention. We can also eliminate the issue of the abundance of actual waste in the future. Further testing of this biomaterial on actual patients with bone fracture will underline its benefits to the whole world. With a costing of just 5 ringgit per 100 gram of hydroxyapatite, it will benefit a lot of people. Thank you for spending your time listening to my presentation, and I hope a very good day to all of my honorable judges. Thank you once again.